Hello and welcome. My name is Sam from Digital Scan 3D. This video is part of a 2-video series where we are looking at hybrid modeling. Hybrid modeling is where multiple modeling styles are combined, such as prismatic modeling and surface modeling. In the last video, we prepared our scan data and cleaned it up for the surface modeling. In this video, we will continue and do the surface modeling, as well as the prismatic modeling, and combine the two into a final hybrid model. If you want to review what is needed to prepare the scan data for surface modeling, you can find the link to that video in the description below. Just to review, in the last video we duplicated our original scan file and renamed the two files for clarification as to which file was the original and which would be cleaned for the surface modeling. We then cleaned up and simplified the copied scan file. In this video, we will generate the surface model based on the surface scan, and then we will prismatically model the flange. So let's begin with the modeling process. In our exact surfacing tab, we can see that we have our auto surface and create patch network options both available to us. Since we are making a surface which we plan to thicken, auto surface will probably not work for us here. So we will need to create a patch network instead. We often call the manual creation of the patch network as just manual surfacing, as it can be compared to just being the manual steps the auto surface function follows. In the Create Patch Network tool, we immediately see a few options at our disposal. Also notice that since this is creating a 3D sketch, we can also switch to the 3D Sketch tab at the top, where we can have access to all of our 3D Sketch tools. While the simplified set of tools in the exact surfacing tab are the minimum required to set up a patch network, some of the tools I want to use can best be found in the 3D Sketch tab. So I will move over to that tab and work out of here instead. Before progressing too much further, I'm going to hide my reference planes. I do not need them for the patch network creation. Now, since we have some boundaries in this model, I'm going to set up some boundaries. I'm going to select my boundaries here, and I'm going to leave it at the medium smoothness setting and say OK. Next, I want to set up some sections, and ideally I want to come perpendicular to the curve and choose some sections that will help define these curves for me. So I can look right here, and as long as they're roughly perpendicular to each other, I'm good. So I'm going to go ahead now and add a few more to help define some of these curves and edges a little bit better. Now that I've created my sections, I can get out of my section tool, and let's go ahead and create some splines. Now with the splines, we're going to go ahead and trace some of these contours of this model. And what I mean by contours is mostly just the flow of this part. So as you can see, I could start at this edge here and start working my way around this part, and just keep in mind how this pipe flows. So starting from one end and keeping a nice general flow or the contour of this pipe. Let's go ahead and add a couple more of these patches, keeping in mind the flow of this 3D scan. You'll notice that some of these lines are blue while others are orange. The orange lines are recognized as contour curves. The blue lines are not. Now, following our contours, we can see that we have a bit of a slight deviation or variation in our shadow here. So I'm going to actually follow that, just keeping in mind the flow of my part. And I can see that it kind of merges right here at this point here. And then I can follow it around the other direction. Once again, keeping in mind the flow of my part and end where I started. It's important to note that when you're making your patches, you want to make sure that they are 4-sided patches. If you have a 5-sided patch, it will fail during the surface creation. So for instance, I have this 5-sided patch right here. A couple ways to get around the 5-sided patch is you can split the patch up into smaller sections. So I can bisect this patch here as long as I continue it to one of my boundaries. Similarly, I would have to do it on this side as well. But if I were to start over here and then cross over here, so for instance, if I were to cross over that this way and bisect it that way, you can see that the four-sided patch, while there is a four-sided patch, it is a very twisted patch. So it's better to bisect that patch a little bit differently here. So I can start at this point instead and then go the other direction. And now, this patch's edges and corners are more square-like, and so a better patch overall. Now ideally you don't want your patches this tight like this, but let's go ahead and see what we get first before we look into modifying that too much. Now just reviewing, just to make sure we have all of our patches as four-sided, which it looks like. This looks good so far. So I'm going to go ahead and say OK with the splines. We can get out of the spline tool, and now we can exit out our 3D sketch. Once again, let's go to our exact surfacing tab and say Fit Surface Patches. I'm going to leave it at these default settings for now and say OK. As you can see, we now have a patch network on our 3D scan here. At first glance, this looks pretty good. But let's go ahead and turn on our accuracy analyzer to see what our deviation to our body is. As you can see, we have some higher deviation at some of these edges and corners. And the reason for that is that this patch is doing a lot of work covering such a large distance. Now there's positives and negatives for having large patches. The positives are that it's easier to thicken, as well as to work on in downstream processes. The downsides are that they tend to be less accurate, especially at the edge of their patch. The way to increase the accuracy of your patches is just to add more patches in those areas. So let's go ahead and go back and fix this. We can go straight to the 3D sketch and edit it. Since we're planning on thickening this surface body, we need to keep in mind that we want to keep our patches a little bit on the large side. While smaller patches are more accurate, they are much harder to thicken. Now in my case, I accidentally forgot to join these two splines together right here. If I were to exit out right now, those surfaces would fail. So we need to make sure that we have a juncture right there. Instead of having to redraw this entire spline, I can just come up over here to join and enter in a threshold for my intersections and say OK. I now have a joint right there. And if I exit out, my surfaces are now generated properly. Now that we have added more splines, let's go ahead and check out our accuracy analyzer. This model is much more accurate. Now, we can go ahead and continue to refine this model to increase our accuracy. However, for this example, we're going to go ahead and say it's OK and continue. We are now done with the surface scan and can hide it. Let's also restore the master scan, which we will now use for the prismatic modeling portion. Going back to the model tab, we can now thicken our surface body. I'm going to make sure I choose the direction 2, which thickens inward, and I'm going to choose a thickness of 0.2 and say OK. The reason for 0.2 inches is that when I check the accuracy analyzer, my result is within the set tolerance value. We have highs and we have lows, with enough areas green in between. If I'm not using the accuracy analyzer, I can also just quickly check and see that I am high and low, and I have good bleed through. Bleed through refers to when two surfaces are on top of each other and both can be visible at the same time and appear to be occupying the same space. Now we will model the flanges. These two flanges will be the easiest to model, as they are just rings extruded upward. So let's go ahead and fit a plane through these surfaces. And I'm going to turn my reference planes back on so I can see these. And I'm going to choose my plane 1 that I just created and create a mesh sketch. And I'm going to resize this mesh sketch to help with any confusion. Say OK. And I'm going to hide my solid body in my meshes. And I'm going to fit some circles. I can just double click. And I can once again also just double click. And say OK. If I want to fully constrain it, I can go ahead and choose the two, set them concentric, and lock them in place. Next, I can go ahead and extrude them to my scan height here. So if I say extrude and flip the direction and say 0.7 of an inch, that's the correct height. And I can go ahead and just say merge operator and say OK. And now we have one of those flanges. Now I'm going to do the second flange the same way. Now that I've finished those two flanges, we only have one left. This is the flange that we've aligned the model to. Similar to the others, it is just a ring. However, there is a spherical chamfer cutout here, so we will just model a circle first and add a spherical cut afterwards. So I'm going to create that mesh sketch, resize it so to reduce confusion, and turn off my scan data. And this time I'm going to fit a circle just to the outside and not to the inside. And I can lock it in place as well. This flange I'm going to model at 0.525 of an inch. I'm also going to set it, the result operator, to merge and say OK. Now let's go ahead and set up our spherical cutout here. On either our top or right plane, we can go ahead and set up a mesh sketch. Now let's go ahead and switch it to rotational method. And for our central axis, let's choose our cylindrical CAD body that we just created right now. We can go ahead and resize this. And we can increase the silhouette range. And say OK. I'm going to hide my solid body and my meshes. And now I have this spherical shape here. I can choose my 3-point arc and grab those two polylines to fit to and accept the fitting. I can go ahead and refine this alignment just a little bit further. And with that, we can go ahead and exit out of our sketch and do a revolve and set the result operator to cut and say OK. We can go ahead and turn on our scan and our solid body and take a look. And here we have that spherical cutout. We can check our accuracy analyzer and see if it's within tolerance. Now, we just have a couple things left to model. We have this casting flash here, which we can go ahead and add in really quick. Just fit a plane there. Create a mesh sketch on top. Resize as necessary. And I'm going to just fit a circle to this shape here and extrude it to my body. And merge. Now, all that's left is to add some fillets to the exterior of this model. So I'm going to open the fillet tool. Start adding some fillets. This last fillet here is very much out of tolerance, and if I try to increase it, it fails over on this side. So we can go ahead and try a couple different methods of how to fix this. First, we can try doing a face fillet and choosing all the associated faces for those two sides and setting it to 0.65. We begin to see where that issue is. It is failing to try to find this fillet portion right there. We can see that it's already too high. So let's go ahead and switch to a variable fillet instead. For the variable fillet, I'm going to just choose some of these points, going roughly halfway around. And I can go back and forth just a little bit until I can get some values that'll work. And that'll both match the tolerance and work for what I'm trying to do here. Finally, we can check the accuracy analyzer to make sure our model is within tolerance. If anything is not within tolerance, we can always go back and adjust it. Since we took a hybrid approach, the majority of this model is relatively simple to update as needed. This concludes this video on hybrid modeling. If you found this helpful, leave a like. If you have any questions, leave a comment. Let us know if you have any specific questions you would like to see a video on as well. Thanks for watching. See you in the next one.